Namaskara. Today we are going to discuss about electrostatics. Electrostatics means it is the combination of two words. One is electron, the next one is statics. Statics means rest. Electron means electricity. So electrostatics, it is the combination of these two words. So electrostatics is the study of charges at rest. Electrostatics is the study of charges at rest. ಗೊತ್ತಾಯಿತು ಇದೆ symbol charges rest, that is electrostatics. See, this origin of this branch of physics, electrostatics, it goes back to 600 BC in Thales of Miletus in Greece. In that place, in 600 BC, people observed that amber is rubbed, it can attract lighter substance. The Greek word for amber is electron, hence the name electricity. That is the origin of the branch of physics, electricity. See, when amber is rubbed, it can attract lighter objects. Even you have seen when the scale or when a pen is rubbed in your hair, and after that it can attract small pieces of papers. You might have experienced, you might have done this experiment. So that means what's happening is when substances are rubbed together, so you know the structure of the atom. Atom has a positively charged center called the nucleus. There electrons and protons are there. The electrons are rotating around the nucleus, you know that. So when the substances are rubbed, what happens is the electrons are transferred from one substance to another. The substance which is losing these electrons will get positive charge, and the substance which is gaining these electrons will get negative charge. So that means when glass is rubbed with the silk, an example if you want I can tell you, when glass is rubbed with the silk, glass will lose electrons. So glass will get, when it loses electrons in an atom, when electron is released from the atom will get positive charge. The other atom which gains electron will get negative charge. So when glass is rubbed with the silk, electrons are transferred from glass to silk. That means glass gets positive charge and silk get negative charge. So this is the reason. So when substances get charged, it can attract small pieces of paper or some other substances. So that is the first introduction you need to understand. After that, it is you have another thing is what is charge. That's what we are going to discuss. So let me talk about the charge. See, in mechanics you learn mass, length and time are the fundamental quantities in mechanics. In the same way, in electricity, charge is the fundamental quantity. From that, all other physical quantities like current, electric potential, voltage, electric power, all physical quantities are derived from charge. So charge is the fundamental quantity in electricity, and its unit is coulomb. What is the unit of charge? Coulomb. But you will be sometimes in your numericals it will be expressed as microcoulomb. Then micro means it is 10 raised to minus 6. Nano means 10 raised to minus 9. Pico means 10 raised to minus 12. So all these prefixes you need to understand. Then because when you are doing a numerical, you need to convert all these units into SI units, System of International. In units and dimensions, you study all these things. So this is charge, the concept of charge. What is charge? Charge is the fundamental quantity of electricity. Now next we are going to, we don't have a board to write all these things. So the എല്ലാം ಗೊತ್ತಾಯ್ತು ಇದೆ ಇದು whatever we discussed today are what is electrostatics. Electrostatics is the study of electric charges at rest. Electrostatics. Then how this branch is originated. So how it is originated? It is in 600 BC, the people of Thales of Miletus, that's a place in Greece, they observed that when amber is rubbed with some other substance, it can attract small pieces of objects like paper and all these small objects it can attract. The Greek word for amber is electron, and hence the word electricity. From that electron, electricity is, that branch of physics is originated. Now you need to understand how this is happening. So when substances are rubbed, electrons are transferred from one substance to another. The substance which loses electrons will get positive charge. The substance which gains electrons will get negative charge. For example, when glass is rubbed with a silk, glass will get positive charge and silk will get negative charge because electrons are transferred from glass to silk. What is the unit of charge? Coulomb. Okay, fine. Now, charge we understood. What are the characteristics of charge? So some important properties of charge. That's what next we are going to discuss. First property is charge is conserved. Conservation, law of conservation of energy, law of conservation of matter, in the same way, charge can neither be created, charge can neither be created nor be destroyed. Charge is conserved. That is the first characteristics. Then the second characteristics is charge is of two types. One is positive charge and another one is negative charge. The third characteristics is, this, like charges repel and unlike charges attract. That is the third characteristics. The fourth characteristics is charge is quantized. That is very important. You will get numericals from that as well. Charge is quantized. That means the charge acquired by a substance is an integral multiple of the basic unit of charge. The basic unit of charge is charge of the electron. See how substances get charged? When electrons are transferred from one substance to another, these substances are getting charges. So electron is having negative charge. You know that. Even in school classes, 9th and 10th, you learned it. So a proton is having positive charge. What is the charge of an electron? It is 1.602 into 10 raised to minus 19 coulomb. That much negative charge. What is the charge of a proton? 1.602 into 10 raised to minus 19 coulomb. That much positive charge. You understood? So this charge acquired, see, when glass is rubbed with a silk, glass is getting positive charge. Then, for example, 10 electrons are transferred from glass to silk. Then the charge acquired by glass is positive. That means 10 into charge of an electron. That means, what is quantization of charge? The charge acquired by a substance is an integral multiple of the basic unit of charge. From that, you can write this equation. I will show you. We don't have a whiteboard here, so I am writing it here. See, Q is equal to plus or minus N E. Q is equal to plus or minus. Here E is the charge of an electron. N is an integral multiple, means N is equal to 1, 2, 3, etc. Q is the charge. The charge is denoted by the letter Q. So this property is known as quantization of charge. So what are all the characteristics of charge? So the first characteristics is charges are of two types. One is positive charge, another one is negative charge. The charge of an electron is negative, charge of a proton is positive. Positive. Second characteristic is like charges repel, unlike charges attract. The third characteristic is conservation of charge. That means charge can neither be created nor be destroyed. Fourth characteristic is quantization of charge. That means charge acquired by a substance is an integral multiple of the basic unit of charge. The basic unit of charge is charge of an electron. That means Q is equal to plus or minus Ne. N is the integral multiple 1, 2, 3, etc. E is charge of an electron. Q is the charge. So what is value of E? Charge of an electron is 1.602 into 10 raised to minus 19 coulomb. That is charge of an electron. What is mass of an electron? 9.108 into 10 raised to minus 31 kilogram. What is charge of a proton? Again 1.602 into 10 raised to minus 19 coulomb. That much positive charge. What is mass of a proton? 1.6 into 10 raised to minus 27 kilogram. That is mass of a proton. Now next we will discuss different properties of charges we discussed. Next important thing we need to discuss here is the Coulomb's law. So Coulomb's law, next is Coulomb's law. Coulomb's law is an example for inverse square law. See, inverse square law. So when you discuss about gravitational law. See, in gravitation you learn about Newton's laws of gravitation. It is inverse square. That means when the distance increases, that gravitational force decreases. In the same way, in this Coulomb's law, that means the force of attraction between two charges, as distance increases, the Coulomb force, the force between the charged particles decreases with the square of the distance, inversely proportional to the square of the distance. Gravitational force, electrostatic force, all these obey inverse square law. But the strongest force in this universe, that means the nuclear force, does not obey inverse square law. That is very important. Nuclear force does not obey inverse square law. So what is this Coulomb's law? See, Coulomb's law states that the force of attraction, Coulomb is a scientist, okay? The unit of charge is also Coulomb. So Coulomb's law states that the force of attraction or repulsion between two point charges means small charge, the smallest charge we can take, between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. That means F is proportional to, so what we discussed is, Coulomb's law states that the force of attraction between two charges, for example Q1 is one charge, Q2 is another charge. So here you can see the distance is r. Then the first statement, the force of attraction, if attraction means if it is positive and negative, repulsion means if it is one is positive and another one is negative. See, the force of attraction or repulsion is directly proportional to the product of the charges, that is F is proportional to Q1 and Q2. F is inversely proportional to the square of the distance, that is F is inversely proportional to R square. Combining these two inequalities, you will get F is proportional to Q1, Q2 by R square. To change the proportionality, you will introduce a constant, that is 1, the constant is 1 by 4 pi epsilon 0 Q1, Q2 by R square. See, this equation is for free space. I will explain you. What is epsilon 0? Epsilon 0 is known as the permittivity of free space. See, epsilon 0 is known as the permittivity of free space. What is permittivity? Permittivity of a medium is the ability to transmit electric lines of force. See, what is electric lines of force? Electric lines of force are used to visualize electric field. Electric lines of force are used to visualize electric field. Magnetic lines of force are used to visualize magnetic field. So the ability of a medium to transmit electric lines of force is known as permittivity, epsilon zero. Epsilon zero is the permittivity of free space. What is the ability of a medium to transmit magnetic lines of force? That is known as permeability. Permeability, that is denoted by mu zero. Permeability of free space. Here epsilon zero is the permittivity. Permittivity is the ability to transmit electric lines of force. So epsilon zero is known as the value of epsilon zero is 8.85 into 10 raised to minus 12 coulomb square Newton raised to minus 1 meter raised. See, from this equation you can write epsilon zero will come here and F will come here. Then the unit should be coulomb square Newton raised to minus 1 meter. We don't have a whiteboard here, so I cannot write it. So coulomb square Newton raised to minus 1 meter raised to minus 2. Even you can write the dimension of epsilon zero. Epsilon zero will come here. The dimension of charge is I into T, because I is equal to Q by T. So we need to convert it into fundamental quantities. That is IT. Again Q2 it is IT divided by R square, it is L square. Then F will come down, that is M LT raised to minus 2. Solving this, you will get the dimension of epsilon 0. So substituting the value of epsilon 0, you will get it as F is equal to 9 into 10 raised to 9 Q1 Q2 by R square. That is this equation. So this equation is for free space. This equation is, we use it for free space. But if there is a medium, if the charges are situated in a medium, for example, if it is in air, the equation will be modified. That is, F is equal to 1 by 4 pi epsilon into Q1 Q2 by R square. This epsilon is known as the absolute permittivity. Epsilon 0 is known as the permittivity of free space. So there is another equation, epsilon is equal to epsilon 0 into epsilon R. Epsilon absolute permittivity, epsilon 0 is the permittivity of free space, and epsilon R is known as the relative permittivity. So that is the equation when there is a medium. So this is Coulomb's law. Then in vector form, Coulomb's law is denoted by vector F is equal to 1 by 4 pi epsilon Q1 Q2 divided by R square into R cap. R cap is a unit vector from R cap is a unit vector from the positive charge to the negative charge. So that repulsive force, the direction is denoted by the unit vector R cap. This is all about Coulomb's law. So that is Coulomb's law. What we discussed today is, the first thing is what is electrostatics, electro plus statics, a study of electric charges at rest. Second point is how it is originated. In Thales of Miletus in Greece, people observed that amber, when it is rubbed, it can attract lighter objects. The Greek word for amber is electron, hence the word electricity. Next thing is, for example, when examples we have given, when glass is rubbed with silk, glass gets positive charge and silk gets negative charge. The reason is electrons are transferred from glass to silk. So glass gets positive charge, silk gets negative charge. So then what is charge? Charge is the fundamental quantity in electricity, and its unit is coulomb. Its dimension is IT. I is equal to Q by T, Q IT. Then what are all the characteristics of charges? Characteristics is charges of two types, positive and negative. Second one is like charges repel, unlike charges attract. Third property is charge is conserved, neither be created nor be destroyed. Then fourth characteristic is charge is quantized. That means charge is an integral multiple of the basic unit of charge. That is, charge Q is equal to plus or minus Ne, where N is 1, 2, 3, etc. E is the charge of the electron. Q is the charge. Then what is Coulomb's law? Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. F proportional to Q1 Q2 by R square. F is everywhere. If to change the proportionality and to equal sign, you introduce a constant. F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, where epsilon 0 is the permittivity of phase space. What is permittivity? It is the ability of a medium to transmit electric lines of force. What is permeability? Ability of a medium to transmit magnetic lines of force. So the value of epsilon 0 is 8.85 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. If the charges are situated in a medium like air, equation is F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Okay, ಗೊತ್ತಾಯ್ತು ಇದೆ? Okay, so today we are stopping. Thank you. Kalu,